Okay, now that we know about heat and energy, and we're talking about phase changes and phase change graphs, now I want to know how much heat is required to either heat something up or cool something down. Okay, so when we talk about this, we're talking about energy. We're talking about adding energy or removing energy, so whether something is exothermic or endothermic. And the other things that we need to know, okay, if I want to heat something up, it is dependent on three things. Number one is how much I have, okay, so mass, okay. Number two, it depends on the type of material. So if we think about this, if I had a bowl of water and a piece of steel, obviously I need the different amounts of energy to heat it up by the same temperature. And the third thing is the temperature. How much I'm heating it up. So it is dependent upon those three things. Okay? When we calculate this, there is actually a formula that you're going to need to know in order to do this. Q is equal to mc delta T. Okay? So what does each of these mean? Q is my energy. Units for energy is joules or just capital J. Okay. M is an easy one. It's mass. Units for mass here is always grams. Okay. And the reason why I'm specifically pointing this out is if I give you something in kilograms, you need to convert it to grams. Okay. Here's this triangle again. That triangle means change in. So this delta T means change in temperature. Now, in order to do this, this is very, very, very important that you calculate the change in temperature the correct way. It is always going to be final temperature minus initial, always. And the reason why I'm saying this is because my temp change in temperature can be a negative. Okay, so we need to be careful that we are calculating it final minus initial. I left the last one, the one in the middle, the C, to last. This is something new. This is my specific heat. Specific heat is the amount of energy needed to change 1 gram of that sample 1 degree Celsius. And the reason why I left this one to last is specific heat is something that I'm going to give you. Specific heat is specific to that particular material. So water has a specific heat. Steel has a different specific heat. Okay? So then truly we're just going to plug and chug. However, there is one thing that I do want to mention. Most of the time we are dealing with water. We are going to heat and cool water, which means you need to know the specific heat of water. The specific heat of water is 4.184 joules per gram degree Celsius. So you will notice that the specific heat of water, the units, has all those units in it. Okay? So in order to heat 1 gram of water, 1 degree Celsius, we need to throw at it 4.184 joules. That is actually an awful lot of energy that we need to throw at it. Okay? Water has the highest specific heat. Okay? So let's head over here and look at this problem. You might want to pull out your book of fun if you haven't already and look to page 4. I gave you some spots for some notes up here, and these next two problems are actually already written in there for you. Okay? So the first one says how much heat. So if I say, okay, heat, which letter am I referring to over here? I'm looking for Q, which means in my problem I better have M, C, and delta T. is required to heat 120 grams. So here we go. Here's my mass, 120 grams. Now, I'm not requiring you to do a 12-step problem, or a 5-step problem, 12-step, don't know where I got that from. 5-step problem. However, with these problems, it is a lot easier to say, okay, this variable is referring to this. This variable, this. Okay, so you know exactly what you have. So my mass is 120 grams. And then if I look at my problem, I'm heating from 30 degrees Celsius to 75 degrees Celsius. So my initial temperature is 30. My final temperature is 75. So my change in temperature is 75 minus 30, which is my 45, right? 45 degrees Celsius. So now I can come up here, I say I have my M, I have my delta T. What about my C? I actually did give you the C. It's telling me that I'm dealing with water. So I know my C is this 4.184. So now I just plug things in. Q is equal to my 120 times my 4.184 times my 45. So the amount of energy that I need, plug it into my calculator, times 45, I get 22,593.6 joules. Yes, these joules will be a large number. Okay, so just be aware of that. So let's look at my next problem that I have listed there. How much heat is required? So I'm looking for heat again, so I'm looking for Q. You're required to raise the temperature of 5 grams. So my mass is 5 grams. And since I'm talking about water, we know C. C is 4.184 joules per gram degree Celsius. And I'm changing my temperature by 3 degrees. So that is my change in temperature. So I don't have to worry about making sure final minus initial. That is my change in temperature. So I have MC delta T. I just plug it in. Q is equal to 5 times 4.184 times 3. And plug that into my calculator. 5 times 4.184 times 3. I end up with 62.76 joules.